Hi guys, my name is Sarah and today we're going to be going over part 2 or level 2 of the remainder theorem. So if you haven't watched the first one, I recommend checking that one out first so that you have an idea of what the remainder theorem is and how to use it. But for now, we're just going to continue. Okay, so here is our practice problem. Given that f of x is equal to 2x cubed minus x plus k and x plus 1 is a factor of f of x, what is the value of k? Well, if we know that x plus 1 is a factor of f of x, that means that we have to set it equal to 0. So, step 1 is first we have to figure out what value of x we're going to be using. We do x plus 1 and we set it to 0 because it says that it's a factor, so it has to equal to 0. So we minus 1 on both sides, and we get that x is negative 1. Meaning that we have to then use x equals negative 1 as our x. So that's what we're going to be substituting. So you can also see it as just this, f of negative 1. So step 2 is now we're actually going to substitute it into our function. So 2 times negative 1 to the third power minus negative 1 plus k. So now that we have this down, we can simplify it. So negative 1 times negative 1 is 1, and 1 times negative 1 is negative 1. And if we do negative 1 times 2, we get negative 2. Now if we have minus negative 1, we have two negatives which make a positive. So it's the same thing as saying plus 1. Then plus k. So negative 2 plus 1 is negative 1, and negative 1 plus k. So now we have that. Now we have to remember that this is being set to 0. This is equal to 0. So now our third step is to actually solve it. So negative 1 plus k is equal to 0. So we add 1 on both sides to isolate the variable k. And we get that k is equal to 1. And now we have to see if this is correct. And it is correct. You can also use synthetic division to figure this out, but this is just how you use the remainder theorem. I hope you guys understood the remainder theorem, and if you have any questions, feel free to let me know and I will try to answer them. Thank you.